Prim's algorithm is another way to do a minimum spanning tree. And this one, you're going to be given one of your vertex, and then you're going to add an edge that's the least weight and connects to the other vertices that are already in the tree, to those that aren't in the tree, and then you keep going until all of the vertices are taken. So this is a little bit different from Kruskals in the sense that you're starting at a point and then you work out from that point. So let's go ahead and take a look at this Minneapolis. And Minneapolis is our starting point, so we are going to go ahead and start right here. Typically, I tell my classes that if you do not have a starting point, start at the letter A or whichever falls the highest in the alphabet or closest to the beginning. All right, so we're going to start at Minneapolis. And in Minneapolis, I have an option of $6.95 and I have an option of $3.55. So $3.55 is going to be my smaller of the two. So that's the first one that I make. And again, this is that same, the same map as before. Once I get here, this vertex is live and this vertex is live. So I could either go $6.95 or I could go $74, $2.69, or $2.62. Clearly 74 is the smaller one, so I'm going to go ahead and select that one. Now we have 3 vertices in play that we can take from. So I have 348, 269, 262, and 695. So I'm going to take the 262. That will be my lowest. And then I now have this one, this one, this one, and this one live. 269, 242, 348, and 695. My smallest one is going to be 242, so that will be this one. And then now my Louisville is going to be live, so I have 348, 269, 695, or 151. So I'm going to hit up 151. Now, the St. Louis now is dead. I can't do the 269 or else it'll make a circuit. So I can't go there. From let's see here. Which one did I just do? Sorry. When I got to Louisville, I should have taken Cincinnati. That's what I should have done. Okay, so now that I'm at Cincinnati and Louisville, it looks like the smaller one is 151. So I apologize about that. I did that a little bit out of order. Now that we have that, from all my live ones, I have 348, 269, 230, 695, and it looks like this 230 is going to be the one that we have to use to capture. So we're going to go ahead and grab that one. And if you look at what this looks like compared to the previous map that we had, this actually looks very much like, sorry, this is getting out of whack here. This looks very much like the other one. Okay, so very similar in the way that we're looking at this. Let's look at another example. So in this one, I'm going to tell you that we're starting at C. So if I'm starting at C, I can go to 2, 3, 2, or 1. So I'm going to go ahead and go to 1 as my option. Oops, that's a little bit too thick. Let me do a little smaller one. So I'm going to go to 1. Now that I have that, I have 3, 2, 2, or 1, because now this one's live. And so 1 is going to be my smallest, so I'm going to go ahead and do that. From here, I can do 2. I cannot do this 2 because it will create a circuit, so that one's off the dock. So I have 3, 2, 1, and 5. So my smallest one is going to be 1, so I'm going to select that. From here, I cannot do 2 because that will close me up. So I can do 2, 4, 3, 5, 3. So I see the 2. I'm going to use the 2. And then from here, I've got 3, 4, 1, 3. Oh, I can't use that because that will close me off. So it looks like 1 is going to be my option here. And I have one more to capture, and that would be F. So I'm going to go ahead and I have the option of getting it this way or getting it this way. And it looks like 3 is going to be my smaller option. So this is going to be my minimum spanning tree according to Prims. So we'll do the monitoring progress in a bit. That's going to be a different film, but you should be in a position where you can successfully do Prim's algorithm.